All right, so we are ready to start our class. Again, thank you for being here in our second meeting for today. So yeah, today we are going to discuss unit number 3. We are going to be working with piecewise defined functions. But before doing that, I wanted to show you something different from our class. And the reason I'm showing you this is because one of the questions that I want to help you to answer is, why do we need to study math in our for our future profession, right? Because some of you might not use math as I use math, right? And the way I teach math is very, well, mathematical, right? But there's that question that always bothers me, because I want to help you to answer that question. Because, to be honest, I cannot answer that question. Why do you need to do math? I cannot answer that question because that's a question that everyone of you will answer differently, right? But what I can do is to help you by showing you how I answered that question when I was studying. So what I do outside of the academic is I do video game programming and a little bit of game development. And there's where I use my math knowledge in another professional topic, right? So right now I'm presenting to you a project of my own where I'm going to create. My idea is to create a 2D platformer game, right? Like Mario Bros. and those things. All right. So as you can see, the first thing that I want you to show you, well, is to show you who is the player. The player is just this tiny square. This is very silly because this is just the beginning. This is just me putting ideas together. All right. But the important thing here is what you are seeing behind all those square and rectangles, all those axes. There's a grid, all right? And there's a coordinate plane, the coordinate plane that we use, that we are learning from, right? The coordinate plane that we are going to use during the entire semester. So there, I believe we are giving value by showing you this. I'm giving value to the skill and knowledge that you are acquiring or acquiring. Yeah, acquiring. Whatever. The skill that you are learning, right? So it is sometimes difficult to picture how can we use math when we just do math just in a piece of paper, right? So my interest is to show you where math can be applied. That's not all. I'm going to show you my idea. I'm just what I want to do, how I'm going to use the coordinate plane, how I'm going to use the functions that we're learning, and how I use here a little bit of trigonometry, the class that goes after this one, or the continuation. Usually there are a few paths after 1146, after college algebra. It could be precalculus or it could be trigonometry. So I use here also a lot of trigonometry. Okay, the first thing that you are seeing is that my player is moving left and right, right? I can pick items. Right now, you are seeing in the middle of my player orange rectangle. That is like, let's call it a boomstick, where it throws these tiny, well, no, they're not tiny here, but with that in hand, I can throw these boxes, yellow boxes, right? And you can see that right now I can throw those left and right of my player. That's it. Now, but my idea is that to be able to aim the location where I want to throw those boxes, well, I'm going to use our coordinate plane. because now when I click on my mouse, right now you are seeing a dot on that, right? Clicking my mouse, clicking my mouse, clicking my mouse. So, and what you are seeing here, well, you are seeing what we are working on this class. We are seeing a point, we are seeing a coordinate plane, we are seeing coordinates that tell us the location of that point. Right? And moreover, we are seeing a ray that is following that point, okay? And that, as you can see, that ray is marking an angle between the ray itself and the x-axis, the right side of the x-axis. See? And there, to do that, I use the trigonometric functions, cosine and sine. All right. So because my idea is to my player be able to throw this projectile not only to the left and right. I want my projectile to go up or diagonal or whatever direction I want. So I will need to use college algebra, and I will need to use trigonometry. I really need to use math to implement my idea into this project. Right now, this is what I just finished yesterday. So my idea is not complete. It's far from complete. This is just the beginning. But as you can see, later, what I can do is to apply these coordinates and the angle, but instead based on the origin of the coordinate plane, maybe based on the player, and then I can point out to which location I want to go my yellow boxes. All right. So that's what I wanted to show you today. Maybe on next class I will show you another project where we use another aspect of the class. But that for today, that is what I wanted to show you, just to show you or to give you my answer on how I use math outside of the academic stuff. Okay. All right. Any question? That said, if you're interested on programming or video game in general, the development, let me know, and if you have questions, I can help you with your question, right? All right. So, unit number 3, we are going to focus on piece wise defined functions, right? And before, this is the workshop of the day, and before going through that, let's just review what we know about functions. So here is the universal notation for a function, where f is the name and x is the input, right? Whatever goes here, we are going to call it the function rule. And the function rule is not other than the equation that we use to get the y value, the output, for whatever is the input is. Right? So this is what we have seen before. Now, what we are seeing is a function that will have multiple rules. So we have this new way of defining a function with multiple rules. It could have not only 2, it could have 3. Is unlimited. All right, and the rule, what is the rule said is, what the rule says is, what is the equation that we are going to use to get the output to the value of the input. Okay, what is going to be the y value for that particular x value. The next thing that you are going to see to the rule is going to be a conditioning. There is going to be if condition 1 is met, use rule number 1 to get the y value. If condition number 2 is met, use rule number 2 to get the y value. All right? So this is the rationale, I believe is the correct word, behind a piecewise defined function. Let's see what we have on the worksheet today. In the worksheet today, we have this example, where, as you can see, we start with the name of the function and the input, p of x. And if you go here, you have this curly bracket, and on the top, we have the first rule. The first rule is the equation x3 plus x. And the condition of that rule is x less than 0. In other words, if our input is less than 0, then we are going to use this equation 3 plus x to get the y value of that point. And that's piece number 1. Piece number 2 has a different rule and a different condition. Condition rule is x squared, the equation x squared, right? And we are going to use that rule or that equation whenever our x is greater than 0 or equal to 0, right? Now, let's put this in practice. And today we are going to focus on mainly on how to graph or how to draw the graph of piecewise defined functions. Any question? All right, so this is what I'm going to do here. The first step here, I'm going to, the first thing I want to say here, for any piecewise defined function where you need to draw its graph, you need to submit or you need to present written work, all right? Keep that in mind for quiz 2 and test. If you need to draw the graph of a piecewise defined function, there's written work that you need to present. So we have this function here. You have 2 pieces, and I'm going to use colors to identify piece 1 and piece 2. We have 2 pieces here. So the first rule, or the piece 1, the first piece of this function is saying use x minus 4 whenever the value of x is less than 2. And I'm going to zoom in just in a moment. And for piece number 2, we had the following rule. Use negative 2x plus 2 whenever x is greater or equal to 2. And that's how we read this function. That's how we read it. Okay, so I'm going to use P2 for piece number 2, and I'm going to use P1 for piece number 1. Okay, that way we can identify or we can name each fragment of the function. All right. So now what I'm going to show you is all the thought process that goes behind solving each piece. So this is going to be longer that you should present as your written work. Okay, so after I do this, I'm going to show you what should be your written work and what steps you can skip. Any questions so far? All right, so from here we know that we have the rule to get the y value. All right, and here we have the condition. Okay, the rule to get the y value and the condition. I'm going to erase this. I'm just going to put rule and y value in parentheses. And we're going to do this in 3 steps. Step number 1. We need to identify, so this is the equation that we have, and we need to identify the type of function that it is. Once you identify the type of function, you want to identify the shape, and more important, you want to identify how many key points you need. Okay, and here is how many key points you need. All right, this is different from the key point that you have in the library of function. Is how many key points you need, the number of key points you need let me put here number of key points and you need in order to draw this function, right? So let's start. The type of function here, this is a linear function. Why it is a linear function? Because we are seeing in the equation that we have 2 terms, and one of those terms contain the variable x. The variable x does not present any exponent, so the exponent value is just 1. Hence, we have here a linear function. So the shape is a line, right? And how many key points to draw a line? How many points do we need? Tell me that on the chat. How many points will you use to draw a line? So that's correct, 2. Okay, so that's the amount of key point that we need here. That's step number 1. Step number 2. Now we want to the condition. We want to work with the condition, right? This is the condition that we have. X is less than 2. So what we need to do here is to understand what are the boundaries of this piece. And when I say that, what we are going to find is, or we are going to rewrite the condition in interval notation. So what is the interval notation here? You can use the number line to help you to understand what will be the interval notation of x minus 2, x less than 2. So here is the number line. And here is 2. If we read the inequality here, it says x is less than 2. So we can represent x value with this yellow highlight. Oh, highlight. Yeah, highlight. With this yellow highlight. Right? So that yellow color is representing the value, all the value for x, because those are less than 2. We know that on the left of that number line, we have negative infinity. On the right, we have positive infinity. So let's focus on this part. From left to right, we start reading from left to right the number line, and we are seeing that there is not pointer, there's no stopping point there. What we have in an arrow, meaning that the left boundary of that interval continues to the negative infinity. There's no boundary. So we use parentheses because infinity is not a number, it's a mathematical expression. So open parentheses minus infinity. Then we stop at 2 because there's a right boundary here for the x value. And more important is that there is an open circle because 2 is not included. So it is strictly less than 2. X value is less than 2, strictly less than 2. So how are we going to represent that here for the right boundary with a parenthesis. All right, so from here we got the left boundary and the right boundary, and you will see why this is going to be important. All right, so let's go now to step number 3. And step number 3, we need to find the key points, and for that we are going to use the boundaries. All right. Okay. The key points are going to be the left boundary, the right boundary, and any other extra point that we need, right? Since what we are going to draw is a line and we only need 2 points, okay? So we are going just to use 2 points. Here's the thing. How are we going to get the left and right boundary? So starting from the left, if we go and look at the interval that we have here, there's no number on the left boundary of that interval. It is a negative infinity. So I'm going to move to the right boundary to see what we have there. And we have the value of 2 as the right boundary. All right, so this is the tricky part, and this is something that you need to pay attention, because having the boundary of 2, I'm going to bend the rule here just a moment, because I'm going to use 2 in the rule for piece number 1. I cannot use, based on the definition of the function, I cannot use 2 for getting a y value with x minus 4, because x here, the condition says x needs to be strictly less than 2. If it equal to 2, then you use this. But what I'm interested in is not the actual, is there any value when x 2 for piece number 1, because there is no. But what I'm interested in is on the location. So this right boundary, what I'm looking for is the location. Okay, so I'm going to use x equal to, and I'm going to use the rule or the equation for piece number 1 with a value that is not allowed to be used by the condition on the equation, but I'm going to use it anyway, because this value is going to give me the location of the right end of the line, and that's going to be important, okay? Because my interest in here is to find the location. So that means that 2 is not included when we plot. I need to write better. Okay, that means that if we plot this location, it's not a point, it's going to be a location, we are going to use an open circle in the coordinate plane. All right. Okay, so what we need to do here? Well, we are going to plug in 2 into x, and we are going to get the y value, which is -2. That means that the coordinate of that location is 2, -2. Okay, and that location is going to be used as one of my key points even though it is not included on that piece, because I'm going to use an open circle, I'm going to consider like one of the key points. All right, so going back to the left boundary, and what happened with the left boundary? The left boundary is not a number, it's a mathematical expression. So what we want to do is then to use any number between negative infinity and 2, the easiest one possible to use here to get a second point for our line. And I'm gonna ask you, what is, you need to choose between negative infinity and 2. And the question is, which of those all numbers is the easiest one to work here? Because what we have here is y equal x minus 4. So we need to pick one x value. But we don't want to complicate ourselves. We want to find the easiest route, the easiest value to work with here. And which one is it? Which one would you prefer to use here for x? Is it negative 1000? Is it 51? Is 51 could it possible? No. Is it negative 81? Which number for you want to use for value, or what value of x do you want to use here? Tell me that on the chat. Answer, yes. 0 is the one that you want to use here. It's the easiest one. We just plug in 0 and we got the y value because the first term get cancelled. All right, so here what I want to point out is that this is a point, because 0 is within negative infinity and positive 2. So we are talking about that we are selecting a point that is included for piece number 1. So we have a point, right? We had that the y value is negative 4, and because it's a point, we are going to use a solid dot, not an open dot, so a solid dot. And then the coordinate is going to be 0 and negative 4. And because we had the 2 points, there's no need for an extra point, right? And there you have it. Those are the 3 steps. And this is long for doing reading work. This is too much, okay? Okay, so what is going to be, or what I'm going to expect you from your reading work? Why are you going to look forward on your reading work? On this exercise, you can shorten this. You can skip step number 1 and step number 2 and go straight forward to step number 3. But also in step number 3, you don't need to write too much. So for an example for a written work should be, this is an example for the written work, right? All this, you know all this. You have all this on your mind. So let's focus on what it is important and are the 2 points that you are going to use, okay? Those 2 points are the ones that are important. So you know that you are working with a linear function, that you need 2 points, and you know the left and right boundaries. Okay, you have all that in your mind. So then you go on your written work and you put here, well, if I need just 2 points, I can select any point value for x, right? Obviously, I need to use my right boundary here, which is 2. This one is the one that is important, and then you get negative 2 for y value, and then the second point, it will be 0 and negative 4, right? So basically you have done, the only thing that I would like you to put, or I will look for, is that you indicate me that this point here is not included. How can you do that? Just putting an open circle there, or putting not included, or putting just location. Okay, put location there, something that tells me, okay, that point is just a location, not is an actual point of that piece, and that's going to be okay. Okay, so see how you can shorten the written work, how you can go and solve this exercise quickly. How the process of how you get to do this is by knowing all this, having all this on your mind. And this is the knowledge. This is the skill that you need to learn. Okay, you having do this, all those process. This is your top process, and you can reach the written work. Is that clear? Any question here on how to produce written work? All right. Once you got those points, this is what you're going to do. Okay. It is tricky, this unit in Alex, because we are drawing the graph of piecewise defined functions, and these graphs are complicated graphs, for lack of a better term. I don't know. So how are we going to do that? We know that we have, so the 2 points, that we got are 2, negative 2, 2, negative 2, right? Let me put this in another way. 2, negative 2, okay, so that's the first one, and the other one, it is 0 and negative 4. See that I'm using a solid dot there, all right? So on this tool set, you are going to use these 2 buttons, the open circle and the solid dot. Make sure that you're plotting in the correct location. Okay, now I have a question for you. Because to draw a graph, we need to connect points, right? If I do this, are you going to, if you do this, are you going to receive the full credit for piece number 1 of this function? Forget about piece number 2. Just focus on piece number 1. Are you getting, if you do this only, are you getting the full credit for this exercise? Are you getting all the credit for this exercise? Is your answer complete? Is that correct? Let me know that on the chat. Okay, anyone? Mason, Anthony, Saet. If you do this and you leave it there, are you finishing with the exercise? Is this exercise complete? What do you think? Okay, so let's do a quick check. Anthony, are you there? Madison, are you there? Syed, are you there? All right. So it doesn't matter if you know the answer or not. Okay, what I want is to talk about this. What is you thinking? If you, what do you think if you do this only? Is this exercise complete? Just focusing on piece number 1. What is your answer? Anthony, you said no. No. Madison, what is your answer? Is it correct or is it incomplete? Syed, what do you think? Is it correct or is it incomplete? Okay, so the answer is no. The answer is no because if we go to the condition here, right? The condition says that x less than 2. So that means that we can continue finding x value to the left. And the left boundary is negative infinity. So how are we going to represent that? With an arrow. Okay? So you put an arrow there indicating that the graph continues to the left. In the Alex, you have two tools that draw a line. One with one arrow and one with two arrows. You want to use here the one with one arrow only, right? And make sure that your line passes through those 2 points. Okay, so we are ready to do piece number 2. Any questions so far? All right, piece number 2. So we have negative 2x plus 2 if x is greater than or equal to 2. And for here, we know that we have 3 steps. Okay, and these 3 steps are not the steps that you're going to write on the written work, right? Remember that you can shorten this, but let's find out. Let's answer all these together. So we need to, in step number 1, we need to find the type of function. We need to know also the shape of the function, and we need to find how many key points, the number of key points we need. All right. For step number 2, we need to get the interval notation. And for step number 3, we need to get the right boundary location or point, the left boundary, and any extra if needed. Okay. So I'm going to give you 5 to 10 minutes. I'm going to turn on my webcam. I'm going to mute myself. I'm going to be here still. So if you have questions, just pick up or write on the chat. But I want to give you a few minutes just to recap what I just said. And I want you to answer me on the chat the answer for each step here. So step number 1, we are looking for the function type. We are looking for the shape. We are looking for the number and how many points, the number of key points that we need to draw the line. I need you to give me the condition, but in interval notation. And then you need to tell me if you have a right boundary point or a right boundary location, same for the left side, and if there is the need of any other point. Okay? Any question? All right, so I'm going to turn off my webcam. I'm going to mute myself for a few minutes, 5 minutes to 10 minutes. If you are done, just write on the chat that you are done, and we can go back to our class. When you have the answers, post those on the chat, right? Okay.